Okay, so yesterday we have created one API and we create a Databricks account and we try to connect our Databricks, not Databricks, Spotify API, Spotify database through our Databricks notebook, right? So today we'll go forward and we'll check what kind of data they are stored, Spotify stored, and we will bring that data into Databricks and we do some transformation. We write some transformation code and save it as a CSV file. So we can use that data in, let's say, creating some dashboard or let's say any business use case. Okay. Okay. Anybody have any questions from the last session?
No, sir.
Okay, great. So no questions. And also one thing yesterday I have mentioned, right? So today I also mentioned the same thing. I attended this session and at the end of the session, we will publish this notebook. I will share this notebook to you. You can modify this notebook as well. Okay. And you can share this notebook. Once you publish, click on publish over here. It will show you one link. Okay, the notebook link, which can access by third-party user as well. So you can copy
Okay,
this
okay.
and paste it in this LinkedIn, so you can get a certificate from Ivy.
Yes, sir. And we can tag the you also, Pratik, sir, Ishani ma'am also.
Yeah, you can tell them
Yeah.
as well.
Yes. So, yes, sir. We will do it.
Yeah. Okay, then we can start.
Yes, sir. Yes.
Okay, let me publish this notebook as well. Okay, copy, done. And in the chat, I have pasted it. So you can open your Databricks account, log in, and click on this link. So it will open. The notebook will be open. You are able to access that notebook. Okay. So you have to create one cluster to run that notebook. Okay. Same way I have created one cluster. So you have to go to this compute and the last cluster I have created, that will not work. So that is the one drawback of this cluster free using. So you have to delete it, or you don't need to delete, just create one compute, give it as a name, some name, Spotify, and click on this create. It will create. It will take some time and it will create. Okay. Okay, then let's move forward. We have, let's run this, shift and enter, it will run. Okay. And I have already installed this library. That's why it's not throwing me any error. And the same code you can use for you, or if you create any API for yourself, you just replace this client ID and client secret. And this is where we are connecting to databases. And remember, yesterday I am saying that sp.recommendation, press tab, recommendation will come. And you have to give some genre. Okay, over here you see the code is written. And let's do one and we will see how actually the data is stored. And we can extract those data. Instead of limit, I keep it as a 1. And instead of seed, I keep it as a pop. Okay, pop means popular genre. And let's save this as a artist. So if you see in the artist, the data Spotify stored as a JSON format. Okay, this is JSON format, and in Python, in Java, it's called JSON format, and in Python, it's called a dictionary. So dictionary have curly bracket. Okay, so that's the easiest way to detect a dictionary. And dictionary have some features. Features is it's a key and value pairs. So you see this one is a key and there is a colon, and whatever written after colon is the value. That's how a dictionary is written. And over here you see also there is a square bracket. In Python, this square bracket called as a list. Okay. And how do we access this value? Let's say I want to access the track, whatever written in the track. So copy this track, and on the artist, this is the dictionary I have saved, right? Square bracket and paste the tracks. It will show you whatever value it contains, the dictionary contains, it will show you. If you want to see the full content, you have to write print. Print will print all the contents. Okay, so there's lots of contents. So now what we actually required from this artist, we actually required the artist ID, because for the name we can give some name, right? And how many name you can give. So we have to do some research. So let's say you are rating name 10, 15 or 20 people's name, and maybe the name, the spelling will be something different, or it should be capitals or different format, let's say Latin word over there. So you can't write the name, or maybe the name is correct, but it can't be detected in Spotify. So best way to access those artists using the ID. But how can you detect those IDs? So this is the one function Spotify provide. Spotify Pi provide the recommendations. The recommendation will give you 100 artists because it's a free API. It will give you the 100. But if it is a paid API, let's say you are paying, so you can gain, let's say, millions of artists. Where is Spotify have? You can extract that millions of artists data. So once we get the artist data, the artist ID, so there is also function called sp dot artist. SP means this Spotify manager. Okay, sp dot I think this is artist. Yes, artist. So artist, and you have to provide the ID in quotes. Once you provide the ID, whatever songs they have, or they are not songs, their whole details, it will be provided. Okay, name, popularity, how much popular they have, type, what kind of type, and this is URI means same again the code. Okay. Now once we get the artist ID, we can find the songs related that particular artist ID. So what we will do over here, we will find the 100 artists. We will fetching the 100 artist detail, and all the artists are related to pop genre. Okay, and then we are extracting the data, only the ID and name. So how are we extracting that? Let's say artist and track, it will show you these all things. Okay, and also there is dictionary. I think let's say do the fast one. So to accessing a list are going accessing by a index. Index means it's a number 0 to increasing number. So let's say a list have 5 numbers, so it will be accessing by 0, 1, 2, 3, 4. So same way we are accessing the first element of the list, it will be the 0. If you run it, so it will give us the all the first list data. Now we want to see, we want to actually get the ID, this ID. Okay. So going to this ID belongs to, let's say, the first and this album. This album dictionary, yes, I guess. No, this, let's find it. So the album dictionary content. So square bracket again, album. And we saw the artist. Yes, ID over here. Okay. So it is artist. Okay, there is also artist over here. So album square bracket, not square bracket, artist. And again, what happened? Artist. So if we go to the artist and you see again there is a list. square bracket. So you have to put square bracket 0 to the access the first element of the list, and inside that list the ID is contained. Inside that list the ID is present. So now we can do the ID square bracket ID, the ID will give it. Okay, so we are accessing this one. Okay, so what we do over here, let's say there are 100 different artists, right? So we are simply running a loop. We are doing the loop for track in result.tracks. So result.tracks will show you all the data these artists have. Okay, and then we are fetching the artist name using the artist 0 and name, and artist ID same as artist 0 and ID. Okay, so this two will fetching the name, the first artist. Okay, and it's stored as a dictionary as an artist, and then we are already defined a artist as a simple empty list, and we are appending this artist name and ID to this list. It will store, so it will be iterated 100 times. So first ID, first, let's say this result will contains 100 artists. Okay, so it will go to this one by one artist. First artist it will go, it will fetch the artist name, artist ID, and convert it as a dictionary name and ID as a key value pair, and then it will store that artist name and ID in this artist list, and it will keep on running until its end. So if I run it, shift enter, and let me check it, the artist. Okay, so if I check it artist over here, you will see a list, a dictionary is created when name is something and ID, name ID, name ID, name ID, name ID, name ID. Okay, so once this name and ID is we have gathered, we use this ID to find whatever tracks or whatever song name this particular artist have in this Spotify database. So we'll fetch all the songs of all these artists. Okay, everybody understood what is happening in the backend? I know it's a little bit programming.
Yes, sir.
Yeah.
Not understood properly, sir, but to watch the video again.
Yes, where you were actually stuck is I think that's.
No, sir. Actually, I am seeing this video.
Mhm.
Then I will perform this by myself on Databricks. Actually, I have done some task on Databricks during my course. I have done postgraduate program in data science. There was one module of big data in our course.
Okay.
But
Yeah, I think I have lost you. Please.
no, sir. Actually, I have not done. We have not done any this kind of a project on it. We have done some sort of a Python programming, little bit of a SQL programming on it.
Mhm. So you have created this whole pipeline like that. There is a one database and the source of the data. What is the source of your data?
No, sir. I have not created. We have learned till the making clusters in the Databricks and those kind of a things.
Yeah. So you want to try to set up, right? All those things, database and.
Like I will do this full project on Databricks now, sir. After watching your two of these videos.
Okay. Okay. Okay.
First,
Yeah,
I'm
nice.
understanding it.
So, so what happened in real life? Think about a retail store. Okay. So in retail store, customers comes and they, let's think about Big Bazaar, right? We already know Big Bazaar and we visited Big Bazaar as well. So you go to Big Bazaar and you search whatever you need. You search different product, right? And you search a different product, and when you check out, the cashier, what he'll do, or he will scan using scanner and scan that product barcode, and it will automatically transfer that what is the value of that image price of that particular product, right? And once all the products is scanned, and he give you one receipt and you paid it, right? So how do you think that all this data is stored in the database? So in big production house, this data will be stored as a NoSQL database, something like this. this key pair dictionary value. Okay, so we call it as a raw data. The data is not modified or structured anything, because that is much more faster, because we are storing the data. That's it. We are not storing in a database. We are storing as a file. Okay.
Yes.
Yeah. So later, data engineer, what data engineer do? First, they will create a pipeline, just getting the data, raw data from local store to your, let's say in HDFS, you are using HDFS, okay, in HDFS storage. Or let's say if you are doing in clouds, so you are bringing that data in Azure blob. Okay. So once you bring the data in Azure blob, then you will make some transformation. Okay, so not all the let's say not all the component is required for your analysis. Okay, and you think and your company thinks that maybe it will require, these columns will be required in future. So for now, let's assume that 200 columns of data is coming. Okay, and out of that 150 columns of data, your company thinks that in future we can use some of the columns, but store it. Okay, so you are collecting all the data, you are extracting all of the data using these loops and using this accessing list or accessing, let's say, dictionary, using this using this loop function, and you are collecting the data as a let's say in a tabular format or as a readable format. Then once you collect this data, you are storing this data in a SQL database or as a tabular format or database format or tables, in tables. Okay, so there your data science team can do run some SQL queries on top of it, and they can do some analysis. Okay, so that's your job as a data engineer. So you have to bring the data, you have to make some transformation and load it to the your final destination. So we are doing the same over here. Over here, we don't have any MySQL database or something like that, but we have DBFS. This DBFS is something similar to your HDFS, and we will see that how HDFS store the data. Okay, once we get the data.
Yes, sir. I think this is faster than HDFS, no? Databricks, the cluster computing.
Yes, Databricks, nowadays everyone using HDFS because it is cheap.
Okay.
And there is one more thing is that your data will be never lost because of
Yes,
this
sir.
factor. Okay, so what actually HDFS do? HDFS create the copies of the data. So let's say if you put 100 MB data in HDFS, it will be stored in a 300 MB. Okay, maybe you think that okay, why should I store it? If I put a 1 GB data, it will take 3 GB space. Then what's the point of doing it, right? So let's think about it. Let's think about this way, that it will create a different block, and it will store different databases or different hard disks, local chip hard disks. They will store the data, and let's say some manufacturing or some malfunction is happen, or maybe fire happen, earthquake happen, and your data center is let's say because of the fire, your all the hard disks are burned, right? So what it will do? All the data will be gone. There is no way you can recover the data. So that scenario replication factor is very good, because the data already copied for somewhere else. That's the one of the benefit of HDFS. That's the reason all the top companies using HDFS. Even though AWS, you see that Azure or AWS or GCP, all of them are using HDFS in the backend, but they are giving you much more faster way to access the data.
Okay, got it, sir.
Okay, so once we gathered all the artist name, so we will find the songs of those artists. What are the songs? So there is one function, artist top tracks. So let's say this is one of the artist ID, and we are fetching all the tracks of this artist. Okay, so let's see. And the tracks is given in this way. Okay, this is also another thing as a dictionary or JSON format, and you will see there's a okay. Let's see the tracks. We want to see the tracks the same way you are accessing. square bracket and tracks. It will show you all the tracks. Okay, and you see there is again square bracket. So in the inside of dictionary, they are storing the data as a list. So accessing a list, you have to use index. Okay, its index start from 0 to 1, 0. It will start from 0 in Python. So it's 0. Let's say it will show the first song's name. Okay, so name of what is the artist? This is the artist section. So artist name is Trey Songs. I have no idea. That is the name. This is the artist. What is the name? Okay, this is the name of the song. Wow. Okay, his playable is true. Then duration. You see the duration it's given as a ms. Ms means millisecond. So we can transform the data, let's say 24,000, 242,013. We can transform this data in a minute and second. Okay, later we will do it. We will transform the data. So we have to fetch from this. We have to fetch. What happened? We have to fetch this duration. Okay. Then name. What is the song name? What is the popularity? Okay, what is the track number is not required, and also the artist name and the release date. Okay, we need the release date. Okay, so we are retrieving this song again. We are running a loop. Okay, so let's think about this way. There is one artist and one artist have 10 songs. Okay, and we have similarly 100 artists. So 100 artists have each and every artist have, let's say, 10 songs. So it will be 1,000 songs. Okay. So this tracks as a list. We are again creating a list and storing all the IDs and the top tracks of that particular IDs. Not IDs, particular artist IDs. Okay. And then from this list, we will create a data frame. Okay, in the new cell, you will see all the tracks. So tracks stored as a list. So we have to use 0. Square bracket 0. Okay, so this is the one artist track. It will show. There are lots of songs. Okay, now we are using Spark. Okay, creating the data frames. How actually the data frames is created. This is very interesting. Okay, you can use Python as well. Okay, Python is much more easier. Why I'm saying as easier? Because it's very user friendly. The code is very user friendly. You have to write and very understandable. Okay, it's a layman terms. The Python code is ready, but in PySpark, the code is little bit tedious sometimes, and it's much more confusing because of this. You see over here, PySpark.sql import SparkSession, and S is capital, and again session S is capital. So this is very confusing to some other people. Okay, so if you write as a small s, it will throw error. So you have to run this as a capital S. Okay, and this is the types. So types means what in the programming language 1 and 1.0. In our normal thinking, we are thinking that the 1 is same and 1.0 is the same, right? Well, 1.0 means 1, but in programming language, these are completely different. They don't think that this is the same. So it's defined by the types. Data types, it's called data types. So I'm sorry, Tarun, you are asking something?
So sorry, sir, really sorry.
Okay, no issue. So these are the types. Let's say I have written ONE1. That is also mean 1, but in programming language, it's a complete different thing. These three are complete different. So this one is defined in Python, it's defined as an integer, int. But in PySpark, it's written as an integer type. This one means integer type. 1.0, I think over here there is no float type. So in Python, it's been float, and you see, you know that it's a decimal. So in PySpark, it's a float type. One means in Python it means string, and in PySpark it's mean string type. And long means, let's say there is a number which is more than 6 digits. Okay, that's an integer. Okay, that's a big integer. But in programming language, it's called as a in Python it's called a big integer. In Python it's called integer. There is no big integer. But in PySpark it's called as a long type. Okay, and this is a struct type. This is one of the class in PySpark to create a data frame structure, and struct field is the same. Okay, and over here you see we are importing SparkSession. This is the Databricks. Okay, so Databricks already run. This Spark is already running behind. But if you're in some other system, let's say you have installed Spark in your local system, right? So first you have to create one SparkSession, then you can use that Spark. So yeah, in Databricks, this SparkSession is already pre-built, so you don't need to create one object of the special object. You just import the SparkSession. That's it. Okay. So now we are creating a schema. So what is a schema? We have already said that we are importing this name. Okay, name. Then we are importing this MS. What it is? MS duration MS. Okay, so we have to specifically mention Spark or the Databricks, this data frame, that this duration type is duration. This is a column name, and the type of this column can consider only long type. Okay, if you put 160 and written 160 as a written, it will throw error. It will not taking as a any input. The same way, the name we will put as a string. It will only accept the string value. If you put 163 or any integer number, it will throw error. The same way, we are defining that we need to create 5 or 6 columns. Okay, the first column is track ID. What is the ID of that particular track, and what is the data type of particular track is string type. And this is one of the function nullable. So nullable false means it will accept the nulls. If you make it as a true, it will accept as a null. But we don't want any track ID as a null, because if the track ID is null, there will be no value, right? So we don't want any null value over here. Same way over here, all those columns, these are the columns. Okay, there's a track name. What is the name of that particular song? And this is also, we are saying it's a string type, and this value also not be null. Null means they are blank. There shouldn't be any blank. So there should be some value in this particular field or particular column. And this column, all this column will combine using the struct type. It will combine as a row and columnar format. So row columnar format mean in Excel you are seeing that there is a ABCD written in the top, and in the left hand side it's written 0, 1, 2, 3, right? That in data frame world, it's ABCD is called as a column, and in the left hand side you see 0, 1, 2, it's a row index, called as a row index. Okay, so first we are describe a schema of this data frame we are actually creating. Okay, so run it. And now we are putting the data inside this schema, using this schema in the database. So how we are actually tracking it? So we have already the tracks. Okay, so this track, well, these tracks have multiple 2 layers. Okay, first layer have the artist. The artist have multiple songs. Let's think about artist have 10 songs. Okay, so first artist have 10 songs, and we are doing over here. You see, we are doing 2 loops for tracks in tracks. So it will be one artist. So this will search the artist Okay, so one artist have 10 songs, and again there is also loop. This loop will be go through one by one each songs, and it will find the track ID of that song, track name of that song, track duration of that song, track popularity, album name, album type, album release date, and artist name. Okay, it will find each and every only one songs, and it will combine using this row append, and it is stored in a list. Same way it will do the all 1,000 songs. Okay, so it will store as a list, and then we are creating a data frame using Spark create data frame class. So create data frame, we are provide this list rows, and this schema we have already defined over here, this schema. Okay, now our data frame is created. Anyone have any questions over here? I know it's a little bit new thing to you, but once you go to the deep, once you go to this Ivy Sports as well, we are already in Ivy Sports. We are go from the basics over here. What is the data frame? How the Spark actually create the data frame in the backend? We'll go in depth. Okay, over here in the 1 hour bootcamp, I can't go in the depth. It will take too much time.
Correct, sir.
Okay, so I am go just showing you how actually it's look like. So in Python, the code is to showing the data. It's a df.head, but in PySpark, it's a df.show. Okay, so the data frame. So we create one data frame df, and now we are seeing that, okay, this is track ID, track name, duration ms, and you see there is a dot is written. So it's actually consolidated or is truncated all those data. But if you want to see the full, so there is a function called truncate, I guess. Yes, truncate equal to false. So if you write false, it will show the full data, but it will looks like a little bit. Okay. So make it is so. Okay, yeah, next over here you can see that. So now you want to select only this artist column, or maybe release date column, or album type column. Only 3 columns of the whole database, right? So in reality, you will get like 150 kind of rows. These not rows, columns. So track ID is a 1 column, track name is a 1 column. But in real life, when you go to this real life job or in real company's job, okay, over there you will see there are 100 minimum 150 columns, this similar kind of columns. Okay, so you have to select only, let's say for a customer point of view, only customer details, right? Customer ID, customer name, so customer address, customer pin code, something like that. So maybe let's say there are 35 or 40 columns, so you have to select those particular columns. So there is the function df.select. You have to write select. Distinct is means the same way. Let's say there is a one artist as a duplicate. There's a duplicate artist over there. Maybe one artist have multiple songs, right? So we want only show that duplicate artist, only show the artist. Okay, only one times they are appeared. So that this is a distinct. It will remove all the duplicates. And over see, if I remove this truncate is equal to false, it will also do this ... It will not show whole thing. What it is. Okay. So for that, if I do this truncate equal to false, it will show the whole name of that particular artist. So df.select is the method in PySpark. In Python, the method is very easy. So df square bracket, have to write artist. That's it. Okay. So if you have a multiple, let's say in Python, if you have multiple column to select, let's say this is the ID, then you want to see the track name. Okay. Then you have to write comma, track name, and make sure you have double square bracket. But in over here in PySpark, you have to write this comma. I guess this will work, or you have to give it as a list. Yeah, this will work. Okay. Now move forward. This is the filter. Okay. So filter condition. Filter condition is something like that. I want to see the artist of James Bay. Okay, so this artist, I want to see all the songs of this particular artist. So the method is df.filter, and inside the parenthesis of filter, you have to write df.artist the contains the name. You can change the name. Let's say I'm changing the name as a list. Okay, and let's so. And you see all the track related to whenever it is listen, it will show you the all the songs. Okay. So this is a filter, and this one some select. Okay. Now the transformation. This transformation is one of the important thing. Okay. The data is given over here as a millisecond. Okay. So if you convert this millisecond into, we want as a 4 minute and 07 seconds. Okay. This format. So in Spark, we use all the classes or all the libraries. So the library is Spark SQL functions. Inside the function, there is a method called floor, lpad, and experience. XPF. So I will explain what is, okay, let's explain what is floor. Floor, we have do the division, right? So let's say we have divided 10 by 2. How can we do it? Using the floor. It will floor division. And let's say we are dividing 9 by 2. So 9 by 2, the remaining will be 4 and the left will be 1, right? So floor will give the 1 value. So we want that value because we are dividing it as a minutes and seconds. So first, what we are doing, you see this floor, we are doing floor duration ms. This is the column name, duration ms, and we are dividing by it is 60,000. Why it is 60,000? Because we are changing millisecond to minutes. Okay. If we are changing millisecond to second, we have to divide it as 1,000. Okay. So once it divided by 60,000 and it's converted, let's say we are dividing this whole number 60,000 and this will give 3 point something, right? So you see over here, it's written 2 and 0. So why it is 2? 2 means after decimal, not 2 means after decimal. So 2 means, let's say there is a number is given 3. Okay. So if I write over here 3 instead of without 0, okay, the 4.07. Maybe it's a, if think about it, is a minutes, but let's say 4 means it can be 40. Okay. If I just write as a 4, it can mean as a 40 as well, right? Maybe it's not possible over here, but it can be 40. So making it as a number 4 as a 04, okay, not 4. So that's why we written as a 2. So all the time, whatever it will be written as a 2 integer. So if it is written 1, so it will be 01. If it is written as 11, then it will be 11. Okay. And that's why 0 is written over here before one number is given. Then what would be the value before 1? So it will be 0. So whenever this calculation is given, let's say 3 point something, so it will be 03. It will be written 03. And same way, this semicolon is coming over here. And this lpad 4, over here you see we are using percentage. Okay. Yeah. So we are using percentage. Percentage means remaining. What is the remaining? Okay. So remaining one we are dividing by the 1,000 because we are want as a second. So that's why we are divided by the 1,000. Again, we are doing the same thing. It's only taking 2 places, and whenever it's given is a 1, it will be 01. Okay. Clear? And we are also changing the name of this, whatever column it will be generated, it will be created. We changing the name as a duration. That's why it's come as a duration, new name. df dot with column. This is the method when we add one column from, let's say, from another column. Any questions or any confusion over here? Where it is filter. Let's say df dot so. Yeah, the duration is coming. So this is a select column. And okay, over here it's a drop. So drop is it will drop this column because we already changed it to the duration. Then we don't require this duration MS. Okay, so we can directly drop it, and then you can so again. Okay, now this one is much more like in SQL. In SQL, we have some queries kind of like this. These are much more analysis questions. So which song is much more popular, and sort the song based on this popularity. So this is ordered by, okay, the column name is popularity. This popularity column will be ordered by ASC means ascending, DSC means descending. Ascending means small to big, and descending means big to small. Okay, now store the data. How do you save the data? So this one already, the Databricks already provide you one DFBS, HDFS. Okay, they have named it as a DBFS. So they are away this name. So this is how you have to save the data. You see there is a Spotify CSV is saving. So now this one thing I want to show how this data is stored. So you see, this is committed success, and then part 00, part 01, part 02, 3, 4, 5, 6, 7, 8. So this is how in HDFS data is stored. So let's say you are storing 1 GB of data, and in HDFS there's a concept called block. Each and every block contains 120 MB of data. So if you upload 1 GB of data, it will divide it into 120 MB. Each and every block will be contains this part 000 will contains 128 MB. Same this 120, same this 120, same this 120, and the remaining one will be contained, let's say 64 or 55, whatever is remaining, it will contain this part file. Okay, so that's how this HDFS data is stored. Once you store, save the data, and you go and you want to read the same data from somewhere else times. Okay, let's say you are go home, you are stop the kernel, and you in the next day you come back and you want to see this data as well. So this is how you read a data in PySpark in Databricks. Okay, the format is CSV. Options header may equal to true or false. Info schema should be true, and this is the standard way to read a CSV file. Okay, if you change the CSV file to Excel, it will change the Excel and change the name over here, Excel. And if you write is there is a different file format like Parquet, ORC, you can change this Parquet as well, ORC as well. It will read the data. Now the problem is one thing, not problem. Let's say you want to store this data in some databases. Okay, so what happened? Database have some properties. Properties means they have some user ID and password. Okay, let's say your company's databases doesn't provide the user ID password. We are talked about yesterday, right? API. So they are providing this a client ID and client secret as well. So you can use the same method over here. We are doing connecting this Spotify database. Similarly, your database will give you a client ID and secret ID, and this similar kind of this code will be provided, and you will connect and you will upload directly this data into your databases. Okay, let me show you one while this, yeah, it's your block. So this is one example where we are running connecting Databricks to Azure Blob Storage. Okay, so these are the storage account key, the container name. This is the value. You can think about as a username or password or API tokens. Okay, so these are the tokens are given. So we are connecting using this token. Then we can read some data, whatever data it's have. Okay, you are doing some transformation. Yeah, over here you see we read the data. Maybe we do some transformation as well. The data is read. Okay. Yes, you see over here there is a multiple columns. There is a 10,000, not 10,000 rows, maybe multiple columns over here, and we are only selecting some columns. Over here, we are selecting 1, 2, 3, 4, 5, 6 columns, and we're saving as a cell details step. Okay. And similar way, we are selecting these product code tables. We are selecting this column and change the column name. Okay. As the company, as your business requirement, we change it. And finally, we store the data, all those modified data into Azure SQL databases. Okay. Over here, this is again the code. Yeah, you see, this is the string, or it's a SQL databases token key. This is the token key. This is the connecting the database. And over here, we are just creating a table. Let's think about this is a database, and this is the table we are creating, and we are loading this DA product code, this data. Just write JDBC and this connection string, and the whatever your database table name. That's simple way. This is so much easy with this cloud nowadays. So that's it. That's how you store the data in the Azure databases. Okay. So Spotify API, let me share it again. I think we already published it. I have published it. Publish, copy, done. Yeah, the link I have provided in the chat again. You can copy, you can use this link. Okay, this notebook will be, you can access this notebook. Okay, you have to use your own computation and run it, and try to change in some over here in pop, instead of pop, change some different genre. Okay, like use K-pop, or use hip hop as well. Use in Spotify whatever their genre is. Use that different genre, or maybe you can use multiple genre as well. Okay, pop and then hip hop. Okay, there is a more popular in K-pop. Okay, you can use K-pop as well, but limit should be 100. Not more than 100. If you make it as 101, it will throw error, because that's the limitation provided by this free API. Okay, so once you have done, you can publish it. Okay, using this publish and this code link, and you can write this in LinkedIn. You have done one bootcamp with Ivy, and we tag with Ivy, and then you can get a certificate from Ivy as well. Any question? Any doubt or questions or any suggestion?
Good evening, sir.
Good evening.
Sir, I had a question.
Sure.
Sir, after especially after doing this work, how we have to post it on LinkedIn? Can you please share once again?
Yes. So once you do this, run this code, there is a button called publish over here. Click on the publish,
Okay.
and then again publish, and you will get a link. Okay. You can copy this link and paste this link in LinkedIn, and you can tag us, and you can write something. I have done Spotify ETL job, or Spotify, the tag we have given, right? You can tag it, give that name, and paste this link in your LinkedIn, and also you can tag us. Okay, tag Ivy.
Okay, sir.
Okay.
Thank you.
Yeah, welcome. Anyone else have any question? Okay, those who joined late, I have pasted the link again, so you can access that link. Okay, then great. If there is no questions, we can call it a day. Thank you, everyone. Thanks for joining.
Thank you, sir.
Yeah.